Pandas is the most popular Python library for data manipulation and analysis, or what we might call data wrangling, cleaning and preparing our data, getting it ready for further analysis. Now, the one thing that we should know before we dive in here is the most commonly used Pandas object is the data frame. It's this two-dimensional data structure. And a lot of what we're doing in Pandas is just manipulating that data frame using Pandas actions. All right? Okay, let's go ahead now and go over into Python and start working with Pandas. So I've got several Pandas examples in this Jupyter notebook. If you want to follow along, a link will be on this page. So also as I go through this, just to note, like these are not all of the possibilities in Pandas. If you want to learn even more beyond this, a great place to go is the official documentation at that link. Okay, the first thing that I'm going to do is I'm going to import the Pandas library, and I'm going to import it as PD. I'm going to use that alias. So when I refer to Pandas later, down in my code, I can just use PD and not the whole Pandas. And I'm also going to import a library called NumPy as NP, but we'll save details about NumPy for another video. So I'm going to go ahead and load these libraries in. I'm going to run my code to do that. And then I'm going to read my CSV file into a Pandas data frame. Okay, so in Pandas, we work with things called data frames, and a lot of the things that we do in Pandas is just manipulating data inside those data frames. And so what I'm saying as I start this out is I have some data at this link. Okay, I've loaded it into the cloud on GitHub. And what I'm doing is I'm saying use the Pandas read CSV function, read CSV, and reading the data at this URL. And what I'm going to do is then once I read it in, store it into a data frame called df homes. So this is going to be data about home sales. I'm going to load it into that data frame. So I'll go ahead and run this. And one of the first things that I can do, which is good practice here, is just check the dimensions of the data. So I'm going to say in my data frame, check the shape of it. What's the size of it? And so as I run this, it's going to tell me that this is the number of records or rows, and this is the number of columns. So I've got 67,000, over 67,000 information about home sales or records of home sales. Now what I can also do is use the info function to list the columns and their data types in this data frame. And again, I'm just referring to it as I've done before. That's where the data frame that I store the data in. And so in the info section, it actually shows us the number of records in this as well, and the number of columns. But it also gives us all the column names in detail, how many of the values are not null, meaning there's information there, and what the data type is that Pandas detected and assigned. Now, integer 64 is a number. It's an integer, like 1 or 5 or 7. And an object is text, which is interesting because what it's doing is it's classifying square footage and sale price as an object. Even though I know that's supposed to be numeric data, which is kind of interesting, that's a good reason why to check your data types and your columns at the start. Just learn as much as you can and maybe find things you need to address. So eventually what I want to do is use Pandas to convert these to numeric data types, but we'll come back to that. Now what I may want to do next as I start kind of exploring my data is previewing the first few records using the head function. Now by default, it's just going to give you 5 or 6 or something, but if you want a specific number, like maybe it's 10, you can just add that in the parentheses. So again, I'm saying go to my data frame and perform some function on it. So what it's showing me here is this is data for home sales in New York City. Every row represents a different sale. And what it's giving us is what's called a borough. So in New York, we have different boroughs. It's like Brooklyn, Manhattan, Long Island. They're just represented by numbers. Then the neighborhood the property is in, the block, the lot, and then there's this easement column, which is interesting because at least right now it doesn't look like there's anything there, at least in what I've previewed. There's a number of units, so there could be, we may be selling properties where it's not just like one home, maybe there's like 20 apartments in the building. The land square footage, the gross square footage in the building, meaning of all the floors, like if it's multiple floors, we're adding that all up together. The year it was built and the sale price. What I notice as I preview this data in the Pandas data frame is I see that some sale prices have dashes in them. And I'm wondering why, or that could be why, when I read in the data, Pandas thought this was text because some of the fields have numbers, some of it has dashes, which is not a number, right? Okay, so that preview function of the data frame can be helpful to get just kind of a quick look at what I've got. Now, what I can also do in Pandas is sort the values in the data frame, kind of like you would sort data in Excel. And so what I'm saying is go to the data frame and sort it. And what I want you to sort it by is the units column. Now, if you look above, remember the units is the number of apartments, for example, or condos in a building. And if I don't put any other options in, it's going to choose ascending, like the fewest number of units to the highest number of units. But I want to reverse that so the highest number is first. So if I run this, I see that I've got the most units, the property with the most units up at the top. Now what I should say here too, which is important for the remainder of what we do here in Pandas, is in this case, I'm not changing the original data frame, just how I'm seeing it in this output. If I wanted to actually change the data frame going forward, what I would do is I would essentially overwrite it or create another data frame with it in it. Now when I've said, okay, make all these changes or make this sort and then store that in that new data frame, that would actually change my original source or my original data frame. But when I don't include that, it's just showing me in this output just a preview of what that would look like. I could also, again, call it something else. Maybe it's DF homes sorted or unit sorted or something. All right, next thing I want to show you here in Pandas is we can select a specific set of rows by position. Maybe what we want to do is we want to say, okay, we want rows 100 to rows 200. We don't want all the data. So what we can do is use an integer location. So I'm still using the name of my data frame first, though. That's going to be common. And I'm saying select rows 5 to 10. Return rows 5 to 10. And this isn't going to like filter your original data frame because you're not overriding it. It's just going to show you rows 5 through 10 in the output. Now, when you're using this, it's going to use 0 as its base. So actually, 5 is going to represent the 6th row. And you see that here because the 6th ID is what we first start with, what's first returned. Now, I can also select a specific set of rows and columns by their position. So in this case, I'm not only feeding it rows, which is what I'm going to provide first, but also the columns. So in this case, I'm saying 5 to 10 and 2 to 5. And that's columns. So rows first and then columns. Now when I run this, what it's going to return is actually only 3 columns. And it's going to be actually the 3rd, 4th, and 5th column, which is a little bit confusing because neighborhood is actually not second, right? It seems like we should start at second because that's what we're providing it here. But 0 is the index. So 0, 1, and then 2, that's the 3rd column, which is going to be the neighborhood. Okay, and it's going to return 2, 3, and 4. So it's going to stop before it gets to 5. So it's saying start at 2 and go up to 5, but stop before it. Okay, so I can use this integer location to select a specific set of rows, which is what I would put first, and then columns. Okay, I can also, similarly, if I want to select maybe like column 2, 7, 9, like maybe they're not all together, I could still select rows 5 through 10, or whatever rows I wanted, and then I could select columns 2, 4, and 6. I could designate specific ones. And what I've done is just I've put these in additional brackets. It's a little different than what I showed up above. Now, if I wanted all rows in this example, I could just erase the rows, leave that colon, and I would get all the rows in these 3 columns. So that's selecting a specific set of rows and columns by their position. I can also select rows that meet a certain condition. It's kind of like a filter in Microsoft Excel. So what I'm saying is in my data frame, go to the units field or column and only show me rows that have more than 100 or 800 units. So if I run this, I see any units or any sales where the units were higher than 800. It looks like there's 6 of them. So there's not that many properties that were sold in New York City that have more than 800 units. That's a lot. Okay. Now, I should reiterate this. It's worth reiterating that, again, I'm not, in this example, overwriting the original data frame. This is just showing me an output of what that would look like. If I wanted to overwrite the data frame to just have, and actually I'm not going to run this, but I just want to show you how this would work, is I'd overwrite this. Okay. I'd say df homes, my data frame is equal to just that result. Or what I could do is I could say, create a brand new data frame and say df homes units greater than 800 or something like that. I could type it out that way. Without that, if I've got it just set up this way, it's not changing my original data frame. It's just giving me kind of a preview of what that filter would look like. All right. I can also select a column in the data set using its name. So data frame homes and sale price rather than using its specific number. Okay, so in this case, I'm getting my sale price, and it's just showing me a preview, the head and the tail, so the first few records and the last few records, just to show me what that would look like. And then if I wanted to select a subset of columns using their names, I'm going to put these in double brackets, and I could put block, lot, and sale price. That's probably less confusing than using those integer locations. You're giving specific field names. And so I'm getting the block, the lot, and the sale price because I've specifically stated that. Okay, now what I can also do in Pandas is drop unnecessary columns. So let's say, for example, that I wanted to drop the ID in the easement column. So say I did some more research on this column and there was absolutely nothing in there at all. Like it wasn't just a preview that had nothing in it. Every single record, 67,000, didn't have any data in that field. So I thought, why don't I just remove that, right? And maybe I want to remove the ID column too. What I'm going to do is I'm going to say, go to my data frame and drop these columns, ID and easement. And what I want to do is, because I actually do want to change the original data frame, I'm going to overwrite it, df homes. And if you want to, you can change this to say df homes consolidated or something like that. But I'm going to overwrite the original data frame in this example. And then what I'm going to do, just to see how that worked, because I know I had 11 columns, I want to check the shape again of my data frame to see if it went from 11 columns to 9 columns after I dropped these two. So I'm going to go ahead and run this. And now I see that there are no longer 11 columns, there's 9 in my data frame, my homes data frame. I can also not only drop columns, but I can rename columns using Pandas. So what I'm going to do in this example is, in my data frame, go to it and use the Pandas rename function. And I'm going to say, find the borough column, which is like the, you can think of it as like the area in New York City. There's these different larger neighborhoods, Bronx, Brooklyn, Long Island. And maybe instead of calling that column borough, I want to call it district. Okay, so instead of borough, I want to call it district. And what I'm going to do is, after I rename it and I overwrite that original data frame, I'm going to check the information about the data frame to see if that name actually changed. So I'll run that, and now I see I no longer have a column called borough, it's called district. It changed that. So it's often a good practice, like as you're making adjustments to the data in these data frames, first of all, we want to do it carefully, but also we want to do some assessments afterward to make sure it actually worked, whatever we try to do. All right, now what I'm going to do here is I'm going to try to convert some columns into the appropriate data types. So when we originally looked at the information or data types for each of our fields, we saw that square footage, land square footage, and gross square footage, as well as sale price, were being listed as objects or text-based data. And we know that's not true. That should be numeric. Now, the reason why it may have done that, like in the sale price, we saw some dashes. And so Pandas may have thought, I see a dash there, maybe there's some text data that I want to preserve. Let's say that we're okay with removing those dashes or not, and maybe there's not any significance to them. What we can do is take each of these fields that were text, and we can use Pandas toNumeric function. Now, before you want to do this, you just want to make sure that there's not anything meaningful to whatever text is in that field. So like if the dashes were meaningful in sale price, we don't want to lose that if it's critical. So let's assume that that's not critical. We're going to convert it to numeric. And what we're going to do is, okay, say take this field, convert it to numeric, and then coerce errors. There's a couple different options here that you can use. But with coerce, what it's doing is it's saying just force it. So if you see anything that's not numeric, basically just remove it, make it null or something like that. Make it a null value. And so we're saying that for all the fields. So overwrite the existing field in the data frame. Okay, take what's there, convert it into something numeric, and coerce errors. So if you find dashes, just remove them, set it as a null value. Okay, so that's what we're doing for those three. Now what I'm going to do is to just check this afterwards, is examine the fields and their data types. So I'm going to run this, and now I see if I scroll down in the info that land square footage, gross square footage, and sale price are float, which is essentially a decimal. They're now numeric. They're not listed as integers, but that's okay for our purposes here. Now, if you do run into an issue where you accidentally make an error and you change something where you didn't want to, what you may have to do is reload in the data into that data frame. Start fresh. All right, the next thing that I want to try is determine if I have any null values in my data set. There may be cases where you want to remove or address null values if you see them, and you probably will see them now because we created some null values and we did that conversion. But what I can do is go to my data frame and say sum up all the null values for every column so I get an idea if there's any there. There's sometimes machine learning algorithms that don't like null values, and so we try to address them or remove those records. You just want to do so carefully. So now I see that in the land square footage, gross square footage, and sale price fields, I've got cells or fields with null values, records with null values, I should say. And so there's a couple options that I could do. I could just leave those as is, or maybe I address them by replacing those null values with a value, or maybe dropping those rows or records. So here's how you would do that. A couple ways of it is if I want to replace all the null values, like let's say maybe for sale price, I wanted to replace all the sale prices with 500. Actually, in this case, it's going to replace any null value regardless of the column. But I'm saying create a new data frame. I'm going to try in this case to change it. And I'm going to say, call it df homes filled, which fills out the null values. And anytime you see a null value, regardless of the field, just fill it with 500. Just fill it with 500. And to check to see how that worked, what I want to do after that is I'm going to filter that new data frame for anything in the sale price that has 500 in it. And there may be some sale prices that were 500, probably is pretty rare, but let me go ahead and run this. And my guess is that these, and this is just showing me a preview because I'm using the head function, but I'm seeing a few rows where the sale price is 500. My guess is that's where I replace those null values with 500. Now you want to be careful about doing this. You could fill it sometimes with the mean or something else, but you just want to be thoughtful about what you're filling it in with and why you're filling it in with it. And then oftentimes you want to fill a specific column and not just all the null values you see. Because in this example, it's filling in 500 with null values in any column, not just the sale price. I'm just previewing the sale price so you can see how it's showing up. So with those null values, you can replace them with something, or you could also drop those records. So maybe what you do is you create a new data frame where you're dropping the null values, drop nulls or something, you could add that onto the end. And you're going to use a function called drop NA, drop the null values. And so you can see up above when we checked or summed up the null values by field, we had a bunch in those three columns. Now if I try to run this, and after I run the drop NA function, if I try to resum it, I see that we've got land square footage, gross square footage, and your sale price no longer with null values because we dropped those records. We just removed them from the data frame. It's not like you're removing them from the CSV file, you're just removing them from the data frame. And if you do it by accident, you can reload the data frame from that CSV file. Just have to go back and do it. Okay. Now, what I'm going to do here is I'm going to actually go back to my original data frame, df homes, and I had just up above created a new data frame, and I'll go ahead and drop those in there as well. And I'm going to going forward, in the rest of my pandas functions, just have a data frame without those nulls in it. You just want to be cautious about when you're replacing values or dropping records, just make sure you do it thoughtfully and make sure you're not losing anything meaningful. Those dashes, for example, in the sale price, maybe there's some meaning behind them that I'm not aware of. Or there may be cases like if you're a teacher and you're grading papers and you have data about student grades, maybe a blank represents a fail. Like if you drop a student who's got a blank value for an exam score, you miss some meaningful information there. So you just want to make sure you're cautious of all this. All right, what I can also do in Pandas is check for any duplicate records. And there's a function called duplicated. And before I actually drop any duplicated records, I just want to sum up duplicates to see how many I have. So as I run this, I see that I've got about 700 duplicate records, duplicate sales. And if I want to actually delete those, I can use the drop duplicates function. And what I'm going to do is after I drop these, replace that data frame, overwrite the data frame. I've also added some options here where I'm saying keep equals last. So let's say that a row is duplicated 2 or 3 times. It's just going to keep the last of that duplicate, the last one, okay, not the first one. So you can adjust some of these with some of these options with all of these pandas functions. Now what I want to do after that is actually sum up the duplicates to see if I've gotten to 0, if I've removed those 700 duplicates. So I drop the duplicates and check that sum again. It now looks like those duplicates are removed. Also, what I may want to do with my data frame is also generate some descriptive statistics. Okay, so I'm going to go ahead and run this. And rather than me writing individually, what's the mean of this field, what's the standard deviation of this field, and so on, describe takes all my numeric fields and generates a bunch of descriptive statistics. Count, mean, standard deviation, and so on. And there can be some interesting information here. So for example, I see that in the year built field that I have a minimum value of 0. To me, that doesn't make any sense because I won't have any homes in New York City built in the year 0 that I'm going to be selling. So I know that's a data quality problem that I definitely want to address. The other thing that's kind of interesting here too is there's a minimum sale price of $0. And there's actually some, if you look more detailed in the data, that have like a $1 sale price or a $10 sale price. And it may just be like a home being transferred to a family member, a child or something like that. So actually looking at the descriptive statistics in detail can give you a lot of interesting information and things you may need to or want to address using pandas. So as an example of that, maybe what I want to do, if it makes sense, is remove homes with 0 in the sale price. Remove homes with 0 in the sale price. And so what I can do is I can say filter that data frame by the sale price and only show me things that are greater than 0. And then when you filter it, overwrite that data frame. And what I want to do is I kind of go through this and remove or adjust records. I want to check the shape to see how that's changed the number of records in my data set. Okay, so what I've got here now is after I drop those additional records, I've only got 30,000 records left and 9 fields. Also, what I may want to do in a similar fashion here is remove homes that have 0 as their year built. Maybe, and what I'm going to do here in a second is create a new column called building age. And if I've got homes with 0 as the year built, that's going to throw off the building age. It's going to look like they're over 2,000 years old. So what I'm going to do then after I remove those records and just show values that are homes that have a year built greater than 0, I'm going to recheck the shape. And I see that dropped I don't know, about 1,500 records or so. I went from 30,000 to 28,000. So I just check the shape to see how that adjusts things. So again, as you perform these Panda functions, you want to just check to see what happened after you ran that, if it actually worked. Okay, next thing I'm going to do, which I can use Pandas for with my data frame, is create a new column. Maybe I want a column called building age, which maybe is more useful than the year it was built. Okay, so maybe instead of, I still have my year built, which is maybe it's 1975, actually having a building age of like 176 may be more useful for what I'm going to do later. And so what I'm going to do is I'm going to say, go ahead and create a new field. I'm just going to say, go to my data frame, create something called building age, which is not there yet. Pandas is going to realize it's not there. And so it's going to create it. And to populate it, what it's going to do is it's going to take the current year, 2022 or whatever it is, and subtract the year it was built. And it's going to do that for every row. And then what I want to do is just preview a few records in the data after I make that adjustment. Okay, so I'm going to go ahead and run this. And I see that I've got now a building age column on the right. And I think that's going to be more useful for my analysis later than the year built. I see this home was 102 years old. When it sold for over $3 million. It has 8 units in it. Anyway, you can add and create new columns in these Pandas data frames. Now, what I also may do is maybe I decide to remove properties that are massive. Maybe for my analysis, I want to focus on properties that are, a more typical home. And so what I want to do is only show homes that have a square footage less than 10,000. Okay. And so for my purposes, maybe that makes sense. And so what it's going to do is it's going to decrease the size of my data, the data in my data frame, to 27,000 records. And now there's 10 columns because remember, we added the building age. Now the thing I can do here in Pandas is use replace in my data frame. So maybe when I'm talking about the district or the borough, like Manhattan, Bronx, Brooklyn, right now it's listing a number, 1, 2, 3, 4, 5. Maybe what's going to be more useful is replacing that with the actual name of the district or the borough. So what I can use with this replace function is I can say, and I want to make sure I've got this in the right order, if I know that 1 is Manhattan, I can put 1 in brackets here and then Manhattan in that set of brackets. And then I know a 2 is Bronx, so I'll put Bronx next. If 3 is Brooklyn, 4 is Queens, and so on. So I can use that replace function. And then what I want to make sure I do is I overwrite the data in that district field. So it actually includes the names rather than the numbers for those districts or boroughs. And then what I'm going to do is just preview the first few records in that field just after the change is made to see if it works successfully. Okay, perfect. I previewed a few records here and I see that Manhattan was listed, and it would have been for these sales. They were all in Manhattan. They all had 1 there previously. Okay, now what I can also do is count frequencies in a categorical column. So we use the describe function to generate descriptive statistics for the numeric columns. What if I want to count categories? Like I want to count the number of sales in certain districts. I can use the value counts function for that. So I go to my data frame, look in the district field, go ahead and enter, and I see counts, and actually is going to sort it from highest to lowest sales. So I have Brooklyn with the most sales in there, 11,000 home sales. I can also convert categorical variables into dummy variables. Maybe for the type of work I'm doing, and I'll actually run this to explain it. Maybe I need something like this. So for every district or borough, I want to create a column, and in those rows, a 0 represents not true or false, and a 1 represents true. So in this with this first record here, the home sale is going to be Manhattan. This is going to give me dummy variables that may be useful for the type of analysis I'm doing later. Anyway, Pandas has that get dummies function to help with that if that's something we need. All right, now let's talk about a couple of more things here. Pandas also has the ability to append rows. So maybe you get home sales every week, and let's assume like the columns are the same and that the data is received the same way. What I could do is I could add last week's sales in one file to this week's sales in a separate file. And to illustrate how that would work, I'm just going to use actually another function in Pandas called sample. And I'm going to pull out a random sample of 10 homes, and I'm going to do that twice. So I'm going to imagine that I have sample 1 and sample 2, these two separate data frames that I'm going to append together. For you, you could be appending together two separate files. I just want to illustrate how this works. But what I'm going to do now is use Pandas concat function, and I want to concatenate sample 1 and sample 2, and then I'll check the shape. What I should expect is that there's 20 rows in this new data frame, the combined sample, because it's added or appended the two separate data frames together. So if I run this, I see 20 records and 10 columns. So we can use concat to append rows. And this is the way it's going to work is we've got to make sure that the columns are the same number of columns in the same order. Okay, maybe again, it's home sales every week. Now, the last thing I want to talk a bit about here is exploring data using pivot tables in Pandas. So like you can use pivot tables in Excel, you can use pivot tables with Pandas also. And so what I want to do is I've commented out several versions of pivot tables so you can see what each of them look like. So maybe what I want is I want to look at district. Remember, that's like Brooklyn, Bronx, Manhattan. And I want to sum or average sale price. So you have to do this in Excel when you're designating pivot tables. You have to say like your row and your columns or your values that you're aggregating by. Similar principle here. I'm also giving it the name of the data frame. But let's go ahead and run this to kind of see what it looks like to maybe have it make more sense. So what it's showing us is a pivot table where district is in the rows, that's my index, and sale price is in the values. It's in exponential notation here, but that's okay. So what I see it looks like is these sale prices are probably being averaged. So by default, if I don't tell Pandas how I want to aggregate the data, whether I want to count, an average, a sum, a min, a max, it looks like it's going to average it by default. So that's kind of my default pivot table there. I can adjust this though, because maybe I don't want to average these. I want to sum up all the sales in those districts. So what I can do is change this. So I still have district as my index. That's what's going to show up in the rows. My sale price and the values, that's what I'm aggregating in my pivot table. But the way that I want to aggregate them is by using a sum. So instead of averaging, I want to sum them. And so if I run this, it's no longer showing the average, it's showing the sum. And what this notation means is E plus 9 just means basically move that decimal point to the right 9 times. And so it's a huge number. So the sum of sales in the Bronx, it's a lot, pretty high in Brooklyn as well. Okay, let's try to adjust the pivot table maybe even further here. So in addition to summing, maybe I also want to show the average of sale price. Again, still sticking with district and sale price, but I want to add not only a sum, but an average all in the same pivot table. So if I run this, I see my sum of sale price, and then I see the average right next to each other. Okay, you can do this in Excel pivot tables as well. All right, let's maybe try this even one step further here. Okay, so instead of just showing the district, maybe I also want to show the neighborhood. Okay, so giving me additional dimension here. I'm still going to stick with sale price as whatever I'm aggregating, and the sum and the mean as the aggregate function. So I'll go ahead and run this. And what I now see is the sum of sale price and the average sale price by district and the neighborhoods in that district. Okay. Now, to kind of close this out here, what I can do is I can store my pivot table in a variable. Okay, maybe I stored in a variable called dfPivot, and let me go ahead and run this. I didn't change anything from the pivot table generated right above this. And what I can do if I want, since I stored this in a variable now, I can even save this or export it to an Excel file. So Pandas allows us to write to a CSV file. And I'm using Google Colab, so I've added a couple extra steps here. But what I'm saying is take this pivot table that I've created and export it to a CSV file and then download it. Okay, so I'll go ahead and run this, and I will download that file of that pivot table that I can open up and take a look at. All right. This illustrates some common functions in Pandas. These aren't the only, but if you want to learn more about Pandas, in addition to running this notebook, you can also go check out the documentation. It's great. They got a lot more information about the library.